Hello everyone. Today we are going to learn about rational expression. A rational expression is the quotient of two polynomials. For example, x minus 5 over 4 or 5 over x minus 2 or 2x over x squared minus 1 and x squared plus 1 over x squared plus 5x minus 6. So these are all examples of rational expression, and we notice that these are quotient of two polynomials. Now let's talk about the domain of rational expression. The set of real numbers for which an algebraic expression is defined is the domain of the expression. But we note that because rational expressions indicate division and division by 0 is undefined, so we must exclude numbers from a rational expression's domain that make the denominator 0. Let's look at an example. So let's find the numbers that must be excluded from the domain of the rational expression. So for this rational expression, x over x minus 2. Now to determine the numbers that must be excluded from the domain, we examine the denominator. Now for this example, our denominator is x minus 2, and we see that this would be 0 if x equals to 2. So we must exclude 2 from the domain of this rational expression. So let's look at another example. So for the rational expression 2x over x squared minus 1, and again, to determine the numbers that must be excluded from the domain, we look into the denominator, and here the denominator is x squared minus 1. And now for this case, we will factor the denominator to identify the numbers that makes it 0. So from previous section, you have already learned that this x squared minus 1 is a difference of two squares, so it can be written as x plus 1 times x minus 1. Now the first factor, x plus 1, would be 0 if x equals to negative 1, and the second factor, x minus 1, would be 0 if x equals to 1. So we must exclude both negative 1 and positive 1 from the domain. Now let's learn about simplifying rational expressions. Now a rational expression is simplified if its numerator and denominator have no common factors other than 1 or negative 1. So we'll basically follow two steps here. So first step is we'll factor the numerator and the denominator completely, and then we divide both the numerator and the denominator by any common factors. So let's do an example. So let's simplify x cubed plus x squared over x plus 1. So first we factor the numerator x cubed plus x squared, and we write that, and we see that x squared is a common factor, so we factor that out, and we write that as x squared times x plus 1 over x plus 1. And we also now write the number that would make the denominator 0. That means we will exclude the numbers from the domain of this rational expression, and we look into the if we look if there is any common factor, and we see that x plus 1 is a common factor, so we can divide them out, and we can write this equals to x squared, and we also exclude -1 from the domain because -1 would make the denominator equals to 0. And this is the simplified expression of this rational expression. So let's do one more example. So let's simplify the rational expression x squared plus 5x plus 6 over x squared minus 9. So again, our first step, we will factor out both the numerator and the denominator. So in our numerator we have x squared plus 5x plus 6, and we factor that in x plus 3 times x plus 2, and in our denominator we have x squared minus 9, and again this is a difference of two squares, and it can be written as x plus 3 times x minus 3. And again, now we will exclude the numbers from the denominator that makes the from the domain that makes the denominator equals to 0, and we look for if there is any common factor to cancel out, and we see that x plus 3 is common both in numerator and denominator, so we divide them out, so we cancel out this common factor x plus 3, and then we write the remaining factors. So we have x plus 2 in the numerator and x minus 3 in the denominator, and we also exclude x not equals to -3, x not equals to 3. So then this is the simplified expression. Now let's talk about multiplying rational expressions, and again we'll follow a couple of steps here. So our first step is to factor all numerators and denominators completely, which is exactly the same step to simplify rational expression. And second step is divide numerators and denominators by common factors. And third step is multiply the remaining factors in the numerators and multiply the remaining factors in the denominators. Alright, so let's do an example. So let's multiply the rational expression x minus 7 over x minus 1 and x squared minus 1 over 3x minus 21. So we factor the numerator and the denominator of each of the rational expression completely. So the first rational expression x minus 7 over x minus 1 is already simplified, so there is no common factor other than 1. And to simplify x squared minus 1 over 3x minus 21, we factor x squared minus 1 as x plus 1 times x minus 1, and we factor the denominator 3x minus 21 as 3 times x minus 7. And then we exclude the numbers from the domain that would make the denominator 0, and in this case x equals to 1 and x equals to 7 would make the denominator 0, so we should exclude this number from the domain. And we see that x minus 1 is a common factor, x minus 7 is a common factor, so we cancel out this x minus 7, and then we look that x minus 1 is a common factor, so we cancel that out as well. And then we are left with x plus 1 over 3, which is the product of these two rational expressions. And we also write the domain restriction, which is x not equals to 1 and x not equals to 7. Dividing rational expressions. So let's divide these two rational expressions. So divide the rational expression x squared minus 6x plus 8 over x squared minus 25 by x minus 2 over x plus 5. So we'll find the quotient of two rational expressions by inverting the divisor and then multiplying. So that means first we'll invert the divisor and we write the division as a multiplication. So in this case we had x squared minus 6x plus 8 over x squared minus 25 divided by x minus 2 over x plus 5. So we write this as x squared minus 6x plus 8 over x squared minus 25 times x plus 5 over x minus 2. So we inverted the divisor. So our divisor is x minus 2 over x plus 5. Now we inverted that as x plus 5 over x minus 2 and we write the division as product. And then we just simply multiply these two rational expressions as before. So first we will factor both the numerator and the denominator completely. So we factor x squared minus 6x plus 8 as x minus 4 times x minus 2 over, and again we factor the denominator x squared minus 25 as x plus 5 times x minus 5, and then we have times x plus 5 over x minus 2, and now we will exclude the numbers that would make our denominator 0. So in this case x equals to 2, x equals to negative 5 and x equals to positive 5 would make the denominator 0. So we should exclude this number from the domain. And now we see that x minus 2 is a common factor, so we cancel this out, and x plus 5 is also a common factor, so we cancel this out, and we are left with x minus 4 over x minus 5, which is the division of these two polynomial. And we also write the domain restriction. X is not equals to 2, x not equals to negative 5, and x not equals to 5. Alright. So let's now talk about adding and subtracting rational expressions with the same denominator. So let's subtract 5x plus 1 over x squared minus 16 minus 4x minus 3 over x squared minus 16. So first, since we have the denominator of both the rational expressions is same, so we'll just simply subtract the numerator and then write that over the denominator x squared minus 16. So in this case we have 5x plus 1 and then minus the numerator of the second expression 4x minus 3, and then we write that over x squared minus 16. And if we simplify this, so we have 5x plus 1 minus 4x plus 3 over x squared minus 16. And now if you add the like term or combine the like term, then you get x plus 4 over x squared minus 16. Now when you add and subtract or multiply or divide rational expressions, then you need to simplify as further as possible. Now here we have in our in this case we have x plus 4 over x squared minus 16. Now we shouldn't stop here because x plus 4 and x squared minus 16 may have some common factor other than 1. So let's factor the denominator x squared minus 16 completely and let's see. So now x squared minus 16 is again a difference of 2 square, x squared minus 4 square, so we can write that x plus 4 times x minus 4. And now we can see we need to exclude x equals x negative 4 and positive 4 from the domain because those two numbers would make the denominator 0. And we also see that x plus 4 is a common factor, so we should cancel this out and we would have this equals to 1 over x minus 4, where x not equals to negative 4 and x not equals to 4, and this is the our desired subtraction. Alright, now let's see an example when we have different denominators when adding and subtracting. So let's add these two rational expressions, x plus 5 over x squared plus x minus 2 and 3 over x squared minus 1. And notice that the denominator of these two rational expressions are different. So now we will follow a couple of steps here. This is as you can compare this with addition or subtraction of two fractions with just numeric fractions. So you need to find the least common denominator and then make each of the denominator equal, and then you can apply the previous rule when you add or subtract fractions with same denominator. So we'll do exact same thing here. So first we will find the least common denominator. Now to do this, we will look into the denominators of each rational expression. Now our first rational expression has the denominator x squared plus x minus 2, and we've factored this out completely. And you have, again, you learned all about factoring polynomial in previous section, so I don't want to talk about that again. So this is equals to x plus 2 times x minus 1. And the denominator of second rational expression is x squared minus 1, and this can be written as x plus 1 times x minus 1. Now the least common denominator. Now to find the least common denominator, we will write the factors of first denominators, so which is x plus 2 times x minus 1, and then we will add the factors of the second denominator to this list. So now so let's put this x plus 1 from this factors of second denominator and put that in our list. And now, and also when adding to our list, if a factor is already in our list, then we will just ignore that. Like in x, for this x minus 1, since we already have x minus 1 in our list, so we don't need that anymore. So this is our desired least common denominator, which is x plus 2 times x minus 1 times x plus 1. Now our second step, so we write equivalent expressions with the least common denominator as denominators. So so we write our problem x plus 5 over x squared plus 2 minus 2 plus 3 over x squared minus 1 equals to x plus 5 over x plus 2 times x minus 1. So here we just factor the denominators completely here, and then we have plus 3 over x plus 1 times x minus 1. And now we will multiply. So now from the previous step, we recall that we found our LCD is x plus 2 times x minus 1 and x plus 1. So we want each of the denominator of these rational expressions equals to the LCD. So we look for the missing denominator, and from the first rational expression we see that our denominator is x plus 2 times x minus 1. So we need x plus 1 to that be equals to the LCD. So we will multiply the first rational expression by x plus 1, and we divide by x plus 1, and we see that the second denominator, the denominator of the second rational expression, missing x plus 2, so we multiply by x plus 2 and divide by x plus 2. And now we will simplify it. So that means we will find this product. So we have x plus 5 times x plus 1 over x plus 2 times x minus 1 times x plus 1, and then plus 3 times x plus 2 over x plus 2 times x plus 1 times x minus 1. And now our step 3 is add numerators by putting this sum over the LCD. So now, since the denominators of both of these rational expressions are now same, so we will just follow the common steps here. So we will just add the numerators and put that over the denominator. So our numerator is x plus 5 times x plus 1, and then we write plus 3 times x plus 2 over the LCD x plus 2 times x minus 1 times x plus 1. And now we simplify the numerator, so that means we will multiply these factors x plus 5 and x plus 1, so we get x squared plus 6x plus 5, and then we multiply 3 times x plus 2, so we get plus 3x plus 6, and then we combine the like terms, so we have x squared plus 9x plus 11 over x plus 2 times x minus 1 times x plus 1. Now don't forget to exclude the numbers that would make the denominator 0. So in this case we should exclude x equals to -2, x equals to 1, and x equals to -1 from the domain, because these numbers would make our denominator 0. So we have our addition. So this is our desired results. So thank you very much, and this is the end of this slide.